How do you decide which large language model to use for a specific application? The best way to do this is by building a benchmark that is customized for your dataset and for your application. You can run that benchmark on multiple models and see how they score, and that gives you a strong indication of where you should start. Furthermore, if you can create a custom dataset like this, you can not only use it to run evals, but also to improve the performance on your application, either through prompt engineering or by fine-tuning on that dataset. I'm going to go through a new library from Hugging Face. It's called YourBench. It allows you to fairly quickly create some questions and answers that form a custom dataset. I'll then run you through evaluations using LightEval, also a Hugging Face library. Now, I've updated the Trelis-advanced-evals repo so that you can also upload Hugging Face datasets and run evals there. So I'll show you how that works too in a nice UI. Last of all, I'm considering starting off a custom eval, or rather a hosted evals service. I've put a link below if you'd like to join the waitlist for that. The two libraries we're going to look at are here, Hugging Face YourBench. I'll put a link in the description. This allows you to create the benchmark, the Q&A, and then LightEval, which is what allows you to run the Q&A on a specific language model. Now, I'm going to put some of the descriptions and some of my learnings in a README file. This will be in the advanced inference repo, which you can get at trellis.com/advanced-evals. Now, the first thing I'll do is I'll run using the UI from Hugging Face, which makes it really easy to create a benchmark and even to run evaluation. But then I'll get into a bit more detail around some of the parameter choices by running this locally, by cloning the Hugging Face YourBench repo and describing how I configure the file. Then I'll go through how to run LightEval. So what you're going to see now is a UI approach. It basically wraps the YourBench approach and also the LightEval approach, allowing you to run everything in just a few clicks. Start off by going to huggingface.co/YourBench Advanced. I'll put the link in the description. And then you'll want to sign in with Hugging Face here. You do need to have some credit card connected to your account because this is going to use some inference services. It might cost a few euro depending on how large of a data set you have and what's needed in order to run the evals. Next, you're going to upload some files. So I'll just re-upload here. You can drop in PDFs. You can drop in, I think, maybe docx. I haven't tested that, or text files probably. So I'm going to go ahead and upload the rules of touch rugby, which is a PDF you'll often see on this channel about a fairly obscure sport that I enjoy playing, but it's a good test case, so it's not necessarily obvious what the rules are to large language models. So I've just uploaded the rules there, and it's now asking me to sign in. And actually at this point, you realize you shouldn't use Safari. So you need to go and use either Chrome or Brave, which I've done by going over here. And so I've uploaded the rules now on the Brave browser, and I've logged in as well. Now I'm going to select an organization because this is where the data set itself that's created will be pushed, and also the eval results will be pushed here too. So I'm going to push it up to the Trelis organization, and I'm going to call it YourBench Touch Rugby, and I'm going to put a -2 just because I ran this earlier. Now I'll click Generate New Config, and it should create a config file that we could download and take a look at. If you do want to look at the config file, you can download it. You could in principle use this to run locally, but actually a lot of the parameters are kind of set in a way that's not suited for running locally. So I'll instead go through how that config file should be set up when I do the local approach. So let's start the task here and get things running. If you want, you can follow through what's happening, but it's going to start by creating a data set with a training split. It won't create an eval split. And then it should start to run eval, LightEval here. And it should start eventually. It won't output the results yet because I need to go ahead to evaluate the models. But I think everything has been completed here. Let's just see. Notice that it's running using the Quen series of models. It's using the 72B model for text, and it's using the VL model for reading PDFs, or rather for reading images within PDFs. So there are a few stages, and I'll go through these again later, but broadly speaking, the documents are being converted into text. That's done using a Microsoft library. Then each of the documents is being summarized. It's useful to have a summary because that can be provided as context when we're asking for questions to be generated. Then some single shot questions are created. What's happening here is the document is being broken into chunks, and each chunk is being sent to the LLM, and the LLM is being asked to generate multiple question and answer pairs. Now the summary is provided as context, so the language model knows what domain these questions and answers and that chunk relate to. So that's the single shot preview. Multi-hop is an extension of that. It's kind of a cool extension. It will take 2 or more chunks. You can specify how many hops, and it will ask the language model to create Q&A based on those 2 or more chunks, which results in more complicated questions because you now are involving information from different parts of the document that may not be adjacent. And once the multi-hop questions are generated, all of the questions are taken and gathered into one data set. So you've got the single chunk questions and the dual chunk questions. That's called the LightEval dataset. And then LightEval is used to run evaluation on a number of models. So at this point here, it looks like we've got the summarization completed. And we're in the middle of single shot question generation. And now we're moving on to the multi-hop generation where multiple chunks are being used to generate questions. Now that pipeline has completed, so we can run the evaluation at this point. And yeah, you just click launch evaluation. So I'd say this approach, it's very nice in terms of just a few clicks. It's less configurable though than if you run this locally, where you can manage the configuration files both for YourBench for question creation and also for LightEval when you're running the evaluation. But still, this allows you to test, I think, 5 models. So it'll be interesting to see how the different models perform. And it's going to push up the results to Hugging Face as well. And with that, the evaluation is complete and it's telling me I can take a look at my eval results at this URL here. So let's just paste it in. And looks like that is failing. So we'll take this approach. We'll give it a few moments to load, but I believe the default is to run on a few different models. So we should have a comparison of how they perform. And yeah, here we go. So it looks like we have 3 models, Qwen72b Instruct, DeepSeek, and Qwen32b scoring 27%. Llama 70b is scoring 20%, and Mistral Small is scoring 17%. So it seems like DeepSeek, the distilled version of Llama 70b, or rather the DeepSeek distilled onto Llama 70b is performing best with Qwen models. And in a later part of the video, I'll show you how private models rather, like Claude and like Gemini-flash model perform compared to that. But this is a very quick way, I think, to get a nice benchmark on some of the open source models and to see how they perform for your custom application. Now that I've shown you how this works using the UI, I'm going to show you how the backend works by separately running YourBench and then running LightEval. So we're going to clone the repos, we're going to do some installs and then run using configuration files. And I'm going to go through all of this. So in the advanced inference repo, you can go, I'm just here in the main branch, and you'll see there's a new folder I've created called resources, YourBench-LightEval. And right in there, you'll see a README file where I'm going to follow the instructions to run this locally. So I'm going to clone the YourBench repo. I'll make sure I'm in YourBench-LightEval. And by the way, I've put that in git ignore, so it's not going to result in that being pushed up to the advanced eval repo. So I'm going to clone and move into that folder. And I'm going to activate a virtual environment using uvvenv. And next, I'm going to need to set some environment variables. So I want to log into Hugging Face so I can push and pull from repos optionally private. I'm going to set my organization as Trelis, and I'm going to set an open router API key in order to call some language models that are not that are going beyond the ones on Hugging Face. Now, open router is an interesting concept. With one API key on which you can put a spending limit, you are able to hit pretty much any model from all of the private providers. That includes, say, Together AI, Fireworks, but also the big ones like Gemini, OpenAI, and Anthropic. And there are some of those API endpoints that are actually being offered free, and Open Router takes advantage of this. So it can be quite a nice option. Even if you don't want to pay, you can find some models that are being served for free. For example, Gemini serves a lot of models for free when it's testing, and Open Router takes advantage of that. So I'm going to go ahead and create a .env file within YourBench, and I'll enter in my environment. And while we're talking about environment variables, I have put in here cursor ignore file to make sure that my variables don't go up. You do need to restart cursor before this takes effect. So if you create it, make sure to restart cursor. And if you're using Windsurf, this should be codeium ignore. So CODE ignore. I've set those variables, and what I want to do now is set my configuration for creating the benchmark. And I'm going to bootstrap from the configs that are available in the examples folder. So if I go to YourBench, and then let me increase my screen size. If I go to YourBench and then I go to example and configs, you can see there's an example file here. This is the one that is kind of easiest to modify. So I'm going to run this copy command to basically copy that example up one level into a configs folder that is going to be within my YourBench folder. So I've just run that, and now we have the example available here. Now I'll walk through this and I'll talk about how to configure it, but to help me out, I'm going to copy an example file that I've put here in the advanced evals repo under resources YourBench LightEval. So I'm just going to take the content of this, copy it, and paste it in here. But you can equally just start with the example one and modify it. So I'll walk through a few of these configurations. First off, you're setting your HF token for pushing and pulling, your organization name, whether you want the repos to be private or not. I'm going to keep them public so that we can all look at them and you can look at them later. And then HF dataset name, this is the dataset name that I want to save it as. And then you can actually concatenate onto an existing dataset so you can keep adding rows. We're not going to do that. We're just going to override if there's one there. There shouldn't be one there, so it should be fine just passing this. Now you can use a local directory, that's included there. Next up, we have a model list. So there are a few ways that you can call models. These are the models that are being used to generate the dataset. One is by using Hugging Face inference providers. Now there are a lot of layers here, so bear with me. There are a lot of paths where you can set models to use, which is good because it's flexible, but it takes a bit of time to understand. So one way you can do it is you can use what's called a Hugging Face provider. What's a Hugging Face provider? Well, if you go to Hugging Face, and then you go to providers, you'll be able to find inference providers, and there basically are multiple. These are not, by the way, OpenAI. These are other ones like Fireworks, Cerebras, HF Inference, Novita, and all of these can work through Hugging Face, I think through your token and through your billing account. So it's possible to basically make calls to Novita through HF Inference, and it will be charged to my Hugging Face account. At least that's my understanding. So to do that, you would set the provider equals to one of these here. Currently, I'm setting it to HF Inference. That's the default, but you could equally set it to one of the other ones like Novita or something like that. Now, another option, if you don't want to use one of these and you want to use OpenAI or Anthropic, you can just pass an OpenAI style base URL. And you could literally pass the base URL for any service that provides an OpenAI endpoint. I don't think Anthropic does. I think Gemini does currently. Many others do. But there's a way you can wrap pretty much any of those by using OpenRouter. So if you pass the OpenRouter base URL, you are then able to pretty much hit any model that is supported by OpenRouter, which is pretty much all of the models. So I'm going to pass in this model here. And to use OpenRouter or to use any OpenAI style API, you also need to pass the API key. So here I'm passing the OpenRouter API key, but if you wanted to pass directly OpenAI, you could pass that key, or you could pass the Gemini key. And last of all, the max concurrent requests, that will just control, and it should be based on your rate limits for that service, which will depend on which kind of account you have. If you're going through OpenRouter, it will depend on what rate limits OpenRouter is allowed. Now, something I should say here is it's very important to use a strong model for question generation because you want really good prompt following. You want to follow the instructions on the types of questions to generate, which we'll get to later. So use a strong model here. Do not use Gemini 2 Flash Lite because that is not a strong model. So probably we should use something like Gemini 2.0 Flash. That's a fairly strong model. I'd expect that will do fairly okay. Now, once you've specified the models here, this is just specifying the available models. It's not saying we're actually using these. So I'm just making these available. I need to choose which ones to actually use. And I need to choose according to each of the steps. So here I'm going to use for ingestion, I'm going to use that model. For summarization, I'm going to use the same model. Now, note that for ingestion, you ideally want to use a vision-supported model because you want to parse the images as well as the text content. So that's why it says use a vision model. The default when we ran in the UI was to use quen-vl and then to use quen here. Single shot questions, I'm going to do the same, and dual shot, or multi-shot rather, I'm going to use multi-hop, I'm going to use flash. Now, single shot, by the way, is a bit misleading. It's not like few shot examples. It's just one chunk. It really should be single chunk. Now, there's one other model here for chunking, and actually this isn't used, and I don't think it works well as of the date of recording this video. But when the chunks are created, you have to decide the boundaries between the chunks. And one way to decide the boundaries is to split them based on sentences. And to go even further, you can try and group related sentences together. So if this sentence is like the previous one, you group it together. And the way you know the sentences are similar is by calculating the embeddings. I mean, this is one way to do it. And so this is the model that will embed each of the sentences if you turn on semantic chunking. And then in principle, it should be able to group the paragraphs by similar sentences. In practice, that is running into issues right now, but the basic chunking works anyway. So probably doesn't matter too much what you specify here. Okay, now for the pipeline, you can decide what things you want to run. So currently, all that's happening is single shot and multi-hop generation, but I am going to want to run every step. So I'm going to change all of these to true. And my source documents, they will be in data raw. So this, I'll have to put in the source documents. We'll get to that. And the output directory is being specified as data processed. Upload ingest to hub. Do we want to upload to hub? Yeah, we can upload our data set to hub. I think that's a good idea. Do we want to run summarization for the global summary of the documents? We can run that. Not entirely sure where that's used. It may be injected into the context of the prompt. We'll take a look at that later. Are we going to run chunking? We are. Now, here's the chunking configuration. So you decide on chunks based on a min and max length. And then you are deciding on a boundary between chunks. So this is relevant if you're using the embedding approach. What's happening within each chunk is it's first being split into sentences using regular expressions. You could use sentence piece. I've used that before in libraries about QA generation. It might be a bit better at finding sentence boundaries, but simple regular expressions are used here. And then each sentence would be embedded. And then the tau threshold is deciding what the similarity threshold has to be effectively between neighboring sentences for them to be put within the same chunk. Now, here's how you decide how many hops you want. This is basically how many chunks to combine. You could make very complicated questions by having, say, 5 chunks. And this here is the maximum number of unique chunks to combine to make a multi-hop set. So currently being set to 5. And sorry, this is minimum, this is maximum. And the number of multi-hops, this is to create a larger number of multi-hops. So we'll get to the detail of the multi-hop script in a second. But the last parameter then you can set is, this is actually not included in the default config, is to have semantic chunking. If there is semantic chunking, it uses embeddings to combine the sentences or to group neighboring sentences. If it's not there, then it doesn't. Okay, so now we get to the single shot question generation and the multi-hop. This is all about deciding how many chunks to create. You can create questions, or rather how many chunks to use for question generation. Here it's saying we're going to use a certain number of chunks. We're just going to use 5, and we're going to select those 5 using this random seed. So this is very not comprehensive. This might be good for evals, but it probably won't be good for training because you're not doing questions on all the chunks. And for training, you would want to do questions on all the chunks. So you want to do all if you're doing data generation. Now for multi-hop question generation, the way it works is you can, again, limit to a fixed number of chunk groups. But alternatively, you can say, I just want a percentage of all the chunk groups. So if the script has set up, I don't know, 500 chunk groups, then you can say, let's create questions for 30% of those. So that's currently what's happening. And let's base the selection on some random seed so we can have reproducibility. And if you turn this LightEval to true, it's just going to take the data set created with single hop or a single one-shot and take the data set with multi-hop and combine them into one data set that you can then use to run evals on. Okay, so that was a description of our config file. And I think we're pretty much ready to go, but we do need to create that data raw folder. So I'll do that. Here it is. And I need to put my document in there. So I'll do that now. Okay, here's the document. 24 pages, by the way. Not a whole lot of text on each page. And now we're ready to run. And to run, it's just UV run YourBench. And then we need to pass in the config file, which we've passed the path to. It's in configs and then example. So we'll get that running. It's converting the data to extract the text from it. It's starting the summarization. And it's now, well, it should, once it's done with summarization, it'll create the chunks, and then it'll start to generate the questions and answers for the chunks. Now, while that is ongoing, I will just give a few advanced notes here on how YourBench is working and some modifications or considerations. So these are just some questions I had and I think are important for generating a good eval. The first is what's used to convert PDFs to Markdown. And the answer is it's Microsoft's Markdown library. This is probably faster than, say, using Marker PDF, which I think is probably a more performant converter to text. So just something to note there. There's probably an improvement you could make, but it would be a bit slower if using something like Marker PDF. How's difficulty estimated? So let's look at the prompts.py. This gives a good sense of exactly how the questions are generated. You can find those by going to YourBench, and then you want to go to YourBench again, pipeline, and there should be a prompts.py in the utils folder. So here we go. And you'll see exactly how this is working. There are quite a few steps involved. First of all, you're being provided with a document. Here's the document to be summarized. Before generating, this is the summarization prompt. So this is when we get the LLM to create a summary of the long document. We're just passing in the long document. Note that the LLM will respond first with a scratch pad, taking some notes on the document before then providing the final summary here. Now here's the question generation prompt. So we've got an input with some instructions. We've got a document title. We've got the document summary. That's where it's being leveraged. And then we've got the chunk. This is for a single chunk case. Now, the goal is to create a few things. I'll just move all the way down here. We're going to create a thought process, first of all. We're going to categorize the question type. So it could be analytical, application-based. This is nice because it just categorizes. Then we'll have a question, an answer, and then an estimated difficulty. So we'll also be able to categorize how difficult these questions are and filter out maybe the harder ones. And last of all, there's even a field being provided here for citations. So the language model needs to be quite strong because it has to provide this for every chunk that's being provided. And actually, it's not just going to generate one question. It could generate multiple questions. And the number of questions generated per query or per chunk or per group of chunks, it's not fixed. So that dynamically allows the language model, if it's strong, to decide how many questions would be appropriate to ask for this given chunk of text. So actually, it's going to respond with a series of these question-answer pairs. So this is how the question difficulty is created. It's essentially part of the prompt. This is also how the citations are created. Note that the citations are not verified. There's no cross-checking with regular expressions. So it's possible the LLM could hallucinate the citations, and potentially there's room to improve there. Now, how does chunking work? Well, we talked about the two types. One is fast chunking. It's literally creating sentences using regular expressions, and then it's combining sentences to be within the min and the max chunk length, or semantic chunking, which hasn't worked for me, but it allows you to have embeddings of the sentences and group them according to the embedding values. Now, how does multi-hop question generation work? Well, single hop, you just have a chunk and you get questions generated for that chunk. For multi-hop, the program will actually take all of the single chunks and then it will generate combinations, and it will create all of the combinations within the hmin to hmax. So you remember back up here, we had to set a minimum and maximum number of hops. So if the minimum is 2, the max is 5, it's going to take all the single chunks and create combos of 2s, all the pairwise 2s, then all the combos of 3s, 4s, 5s. So it's going to have a big set of chunks of all those, a big set of combos of those chunks. And once those combos are there, it's then going to down select by a factor of this factor we set. So if there's a total of 1,000 combos, it's going to down select by a factor of 2 to give 500. And then it's further going to down select by the percentage when it comes to the chunk generation or to the question generation. So actually, we've already down selected here, but we're further going to down select when it comes to the question generation to only pick 30% of those downsample chunks. So if you started with, say, 2,000, down select to 1,000 because of that factor of 2, and then take 30% of those would be 300 questions. Now, does this repo support evaluations? No, this does not explicitly. When I say this repo, I mean the YourBench repo. It's designed to be separate from LightEval, so it's generating questions, and then you use LightEval to evaluate them. Is there any data filtering? So once we create the questions and answers, do we deduplicate? Currently, there isn't any deduplication or filtering for, say, just empty answers where the LLM fails, but I think that's something that's going to be put within the library a bit later on. So you do have to be careful. There might be some questions that are just not great because the LLM failed to generate a coherent question and answer for a chunk. Are the question and answer generated at once? Yes, they are. As I showed you in prompts.py, both the question and answer are generated, and in fact, multiple questions and answers are generated. This is different than the synthetic approach I earlier took, where I'll get language model to create questions first and then create answers. There are some pros and cons. If you do questions and answers together for the one chunk, at least your questions are probably not going to be overlapping. So that's good. That's also why I previously generated all my questions at once or in groups. If you get it to generate both questions and answers, you could argue maybe, I don't know if you're burdening the LLM with having to generate a lot within a single pass and you're putting a lot of context. So maybe that is a drawback. But broadly speaking, I like this approach. I think it makes sense to create questions and answers in one go. If you have a strong model for generating those, I think it should work well. How many questions are generated? I answered this already. It's not a fixed number. For every chunk or group of chunks, the LLM decides how many question-answer pairs are appropriate. Now, some other more advanced FAQ. What's the scratch pad? This is just used actually in the summarization prompt. It's basically like thinking. The LLM will emit some scratch pad or thinking tokens before it then gives the summary. Does the question generation go across document? No, currently the chunks are only grouped, I believe, according to a given document. So the questions are created, QA are generated for each document, and then you iterate through each of those. So there's room for improvement here to do some cross-document generation. The summarization is done now, and that means we're ready to move on for chunk generation. I think I have a data set that's being pushed up to YourBench example. And now we have chunking happening. And we should then have the calls for doing the single hop, which is here. And then we should have the calls for the multi-hop, which is happening down here, multi-hop questions and answers. And once everything is done, then those two data sets should be combined and pushed up to Hugging Face. So let's go up anyway to Hugging Face and we'll find YourBench example. And now you can see the chunk document has been uploaded here. You can see the ingested file momentarily. It's the touch-rugby rules, which looks good. And then you've got the single shot and the multi-hop questions. So we have 24 single shot questions generated from 5 chunks. So you can see an average of 5 questions per chunk. And then we have 38 questions from multi-hop. And we also have a summary of the document, which is uploaded here, along with the scratch pad. So let's just go to the settings. I'm going to rename this to touch-rugby-benchmark 2. And with that, we're ready to start to run evaluation. So to run evaluation, we're going to go to the README again and move on to this section about using LightEval. Again, we're going to clone the repo. We're going to move into the folder and we're going to install. Now, in principle, you don't need to clone because you can just pip install LightLLM. In practice, though, we need to generate a task file that's specific to YourBench. And to do that, it's easiest to clone because there is a sample script within LightEval that allows you to generate a task file for YourBench. Also, this may be fixed by the time you look at this video, but currently you need to pip install Light LLM Maths, otherwise you'll have some package dependencies missing, and you also need these dependencies here for everything to work. So I'm going to cd back into the YourBench LightEval folder, clone cd, create a virtual environment, and then install here. And I am getting this error, but we're going to proceed anyway, and hopefully this will work. Now, I said we need to create a task file. So LightEval works by passing in a task file, which defines the judge that's going to be used and the LLM that's going to be used for that. And it also defines the data set. Well, you pass the data set into that task file, but you do need to decide what the metric is for evaluation, which is going to be an LLM as judge. That's what we're going to use here for eval. So the syntax for calling LightEval to create a task file is LightEval tasks create. Then you need to pass in the file or the script that's going to actually create the task. Sorry, I know this is very meta, but essentially we're running LightEval. We need a task file for that. And to create the task file, we're going to write a script that's going to create the task file for a given task name, which we're just setting here. Make sure you include the apostrophes, and then for a given repo. Now the repo we want to include is the one that we've just pushed up to hub. It's this one here. So let me copy that in like this. Oops. Copy it in like this. And now we should be in a position to run and create that. Okay, so that's run successfully, and it should have created this custom YourBench touch-rugby-task.py. So if I look within, now not YourBench, I need to look within LightEval, and I have my custom file that's just been created here. And notice how it points to my data set. Now there's one thing we need to change, which is the subset that we want to run on. The subset, if I go back here, is actually LightEval. It's not LightEval single shot questions. So I need to modify that. Now that's also probably a bug that will be fixed, but I've currently noted that there. And now we're in a position to run evaluations on this. And to do so, we need to run LightEval with an endpoint. This is if we want to use Hugging Face inference providers. So we provide the model name, the provider, which would be HF inference if we're using Hugging Face inference. And then we need to pass that we're using a custom task, the name of the task, which is going to be the name that we gave up here. So it needs actually to be YourBench touch-rugby. And then we need to pass in the file that we just created, which is this file here. So I think I can run this. Am I pointing to the correct task name? I think I am. And I'm going to run. Now, in principle, you can also use OpenRouter or OpenRouter. And you would do that not by passing a provider, but by passing the base URL and your API key and the max concurrent requests, which would look like something here. And so we have hit that error here around LightEval, and we're going to address that by installing LightEval. You do need to put the inverted commas like this for the install to work. And I had to install disk cache as well. Not actually sure why I didn't see that earlier. And here it looks like I have another issue. If I go into my file, this needs to be a string. And I did run into this issue earlier. I thought I could overcome it just by putting in the inverted commas when I run this here, but that actually is insufficient, it seems. So I'll rerun now. And it's giving me the same issue for setting the repo. So again, I need to go in here and make sure this is being passed as a repo, as a string rather. And now it looks like things are running. I will add in disk cache up here just so you don't run into those issues. And we are running now. So we're running 62 questions. That's the combination of the multi-hop and the single hop. And we should see our results then appear within a results folder within the LightEval folder right here. And something I should note just when we're running this is the choice of judge. So if you look within your config file, the judge that's being used is actually GPT-4o currently. So you might want to change that to decide on what an appropriate model would be. But this is being coded in as a selection. So just so you're aware of that. So the evaluation is being run and we're computing the metric. This here is just a warning. It's not actually a failure. The results are now saved. If we go up to results and we can check them out, they're in the Quen folder here. And it looks like out of those 62 questions, we've got an accuracy of 16%. So this is a measure of how good the Quen model is. And you could then look at the performance of other models and see. Now, I've gone through things very fast here and I haven't inspected my data, which is very not recommended. I'm going to inspect it now in the next part of the video, but you really need to check manually that the questions make sense and that there are no dud questions either, and filter those ones out as well. Otherwise, you don't really know to what extent this is going to be meaningful. I suppose at least if you run the same data set on multiple models, it's going to be apples to apples. So maybe the relative scores are still somewhat correct, but the absolute score won't make so much sense unless you actually review some of the questions and check that the whole pipeline is working well. So this is it for the scripts demo of both YourBench and LightEval. I'm now going to move and actually import the data into the advanced evals tool that I have here in this repo, and that will allow us to inspect the data and also run some evals from that interface. Now, for the last part of the video, I'm going to use Trelis-advanced-evals framework. There are two previous videos explaining in a lot more detail how to think about creating evaluations for your use case. And I'm going to extend this now by allowing the import of Hugging Face datasets, namely the one that we created today. And then I'll show you how we can inspect the data and run evals from the advanced evals tool. Now, this is a web interface. If you open up rather the advanced evals repo, and then you run some of the installs, just make sure that you're in the root folder. So I'm here outside of resources in advanced evals, and I'm going to run the installations. You do need to set up the database. If you want to follow instructions, take a look at the very first video on this. And once your database is all set up, I'll use Postgres, you can run the client interface. So the client interface now should be up and running. You can check, this is just some information on the database status. And then you can click open to get to this user interface here, where you can add in data sets, and then you can define pipelines for evaluation. Now, the data set we want to import is going to be the one we created, and we're going to use this new import from Hugging Face feature here to import the touch-rugby-benchmark 2 data set. So I'm just going to pass in this dataset slug. If it's private, you can pass in a token. It's not private, so we should be fine. And we're going to pick a subset. So here I'm going to put in LightEval. It's the split here. Sorry, not the split, the subset. And then, yeah, I think it'll just default to main, but we want the training split because there's just a training split here. So next, I'm going to define the judge type. Now, this is something I talked a lot more about in the earlier videos. There are two ways I talk about doing LLM as a judge. One is having a judge compare the ground truth to the actual answer. And the second is to have the judge compare the answer to a set of criteria. And I like the criteria approach because it tends to be more flexible in identifying and more accurate in identifying what the aspects of a good or bad answer are. If you have a ground truth answer, the model that's the judge has to come up with what it needs to see in the actual answer. And it's a bit subjective what exactly from the ground truth needs to be in the actual answer to consider it correct. Whereas if you have a bullet list of criteria, the model is much more easily able to say, right, those criteria are included, and therefore this answer is going to be correct. However, the way that the YourBench benchmark works is creating ground truths. It doesn't create evaluation criteria. So we're going to have to import the data set using a ground truth judge. Now, in a follow-on video, I'm going to show you how to create data sets for doing training as opposed to just benchmarking. And there I will provide support for criteria-based question and answer data sets. Okay, so we'll select ground truth, click on next, and you can take a look at your logs. You can see that everything is importing. It's got the available features. And let's see if it's correctly getting the data set. Yeah, so what's happened here is it's imported the data set and it's now going to ask me to assign to map fields. So I'm just going to put in a username here, Ronan Trelis. I'll say touch rugby questions from YourBench. And I need to assign the question field, or rather I need to assign one of the fields in this data set. So one of these fields to the question field in the evaluator. So I'll just set that as question. Evaluation criteria field. There are no evaluation criteria provided here, so I'll leave that. Ground truth field is going to be, what's it going to be? The ground truth answer. And then you can import a document as well. This document, though, in the advanced evals type framework, it's used actually as context. So if you want to do benchmarks where you include documents included in the context, that's where you would include a document here. That's not what we want, though, because we're just doing questions and answers with no context in this case. So we'll continue here and import. All right, so now we have all of the questions, and a quick scan through just there shows me things are looking good in that none of the questions kind of failed to generate. So that's a good thing. If there is an issue with one of the questions, you can go in and edit and take a look here at what the ground truth answer is. And you can modify that if needed, and then you could save the task. But this looks pretty good for now. So we can consider running an evaluation from right up here. And we're going to run a ground truth-based evaluation. If you try to run a criteria-based one and click update method, we've got a big list of errors because basically it's saying all of these tasks here don't have any criteria specified. So that's why that won't work. But we can run a ground truth-based evaluation. And let's test out the performance of Gemini-flash. So you've got a whole range of different models that you could select here. If you want to update and add another model, you can go to the pipelines, create a new pipeline, put it in here, my Claude pipeline. And we'll say this is a pipeline to answer questions using Sonnet 3.5 with no system prompt. So you could pick the provider, pick claude-sonnet, pick the temperature, we put in 0.1. And you can then define a system message, which I'm not going to do. You can also include few shot examples actually drawn from the dataset. I'm not going to include few shot examples. If you want more on this, you should look at the first or second video and then save the configuration. So that now should appear as my Claude pipeline. It's down here, and we can use that if we want to evaluate. So here, if I go into the dataset, I can run my Claude pipeline, or I can run just a simple Gemini-flash pipeline with no system prompt as well. So we'll run the evaluation here, and it does support parallel calls to the LLM. So that's why you'll see the tasks are being done quite rapidly here. And yeah, so basically we've completed all 62 tasks, and it looks like it's got 25 out of 62 correct. We can take a look at some of these questions, for example. So you can see what's the definition of the field of play in touch rugby, touch football. To be honest, that's not a great question. It's a bit too vague for the language model to know. Yeah, again, this question here, I don't particularly like. What does full-time indicate? It's kind of not a specific enough question that I would want. What does the term forward refer to in touch rugby? Yeah, again, this is not a great question. So this is why inspecting the data set is important, and then probably iterating on the prompt for generating questions and answers before you decide to just run evals like this. Again, here, let's look at, yeah, what does imminent mean? I guess this is maybe not a bad question because there's a concept of a touch being imminent. And when it's imminent, the defenders are allowed to retreat. So this is not bad. And you can see here the judge's explanation of whether this question was correct. You can also check what the judge's exact prompt was. Here's the pre-prompt for the criteria judge. Here then is the question being passed in, and then the ground truth. So you can see the ground truth is passed in, and then the model's answer is being passed in, and then a score is being assigned here. So yeah, this is allowing you an easy way to evaluate. You can really read the answers pretty quickly. And then if you wanted, you could go back to the data set and modify any of the questions that you have here. Or alternatively, you could decide to run a different pipeline. So for example, we could run my Claude pipeline, and we can run it on ground truth. And this is basically answering the question of using this very quick generation method and without doing a lot of inspection, which I don't recommend, I can see whether Gemini-flash or Claude is better on the domain of touch rugby. And my guess is maybe Gemini-flash. I think it for some reason is better based on my prior experience. Okay, I'm wrong. So actually Claude, according to this set of benchmarking, is scoring 34 out of 62. So it looks like Claude actually does have a better understanding of touch rugby than Gemini-flash, subject to the caveat that I did not do a lot of data inspection, and I will be doing in the next video for explaining on fine-tuning for reasoning. But you can see very loosely how you create an automated data set based on documents, then evaluate it using different models, and then compare the performance of those models. Now, I said at the start of the video, I'm considering this is available already in advanced inference, so you can get access by purchasing that repo or as part of the multi-repo bundle. But I'm considering offering a hosted version of this, and I've got a waitlist below in the description if you want to try out that link. To create a custom benchmark for your application, you can use Hugging Face and use YourBench followed by LightEval. With YourBench, you can just take documents and generate question and answers that will form a benchmark from it. And once you have those, you can relatively easily run LightEval on any model using something like OpenRouter in order to evaluate which of the LLMs is going to be best on your given application. In principle, you can also use this kind of a data set to improve the performance of your model by doing some fine-tuning, and that's something that I'm planning to cover on a future video on reasoning. As usual, I've put some links below in the description, and let me know if you've got questions down in the comments. Cheers, folks.